guys, this is Rifat Shahrukh. I'm the Chief Technology Officer and Lead Scientist of Space Kids India. We built one of the world's lightest satellite called KalamSat back in 2017, and we have built more than 16 space missions in past 5 years.
I want to become an astronaut when I grow up.
When I grow up, I become a scientist.
After I grow, I want to become a NASA scientist.
We as young generations are pressurized by our parents to join these careers such as medicine, engineering and then MBA. What I feel personally is there is a life more than that. There's an entire space to explore. And I personally had a big dream to make a satellite when I grow up.
After watching all of this, we get a lot of requests from students around the world that they also want to be part of space exploration and want to build their own spacecraft. So we are coming with the answer finally. Let's go and explore the space together and make the humanity spacefaring nation.
A very good evening, ladies and gentlemen. TEF takes immense pleasure in welcoming Mr. Rifat Shahrukh, a young scientist for today's event of Knowledge Enrichment Program. We would like to thank Mr. Rifat Shahrukh for accepting our invitation and joining hands with TEF in the Knowledge Enrichment Program in developing young scientists. Guys, are you ready to fly your own satellite? Yes. This is going to be an awesome experience and would like to make this session more interactive where everyone gets benefited. For sure, TEF is expecting more satellites in the space from all of you by gaining the knowledge, and all are welcome to ask questions and interact at the end of the session. Now, I invite Mr. Sri Ganesh, Head Cultural Department Committee, to present the welcome address before we proceed. Thank you.
Good evening, everyone. I welcome all TEF members and guests for this August gathering today evening. I take immense pleasure in welcoming our guest speaker for today, Mr. Rifat Shahrukh. Mr. Rifat Shahrukh comes with over 5 years of experience in executive leadership of space and nano satellite technology support operations within the space industry. He has also been a dedicated team member in providing advanced system support infrastructure and tools to corporate structures. He has been instrumental in developing one of India's leading private space organization. He is currently working as the Chief Technology Officer in Space Kids Chennai. He has led and developed indigenous CubeSat and Pocket CubeSat subsystems into the orbit. He has also led the development and successful launch of 2 CubeSats into the orbit and 2 suborbital payloads into the orbit. He has created a strong team for exclusive research in nanosatellite systems. He has also been instrumental in creating one of the most economical yet powerful nano and picosatellite bus for student and research community. Prior to this position, he was also holding the position of student journalist with Vikatan Publications. As you all are aware, Vikatan Publications is a very famous publication in Tamil Nadu, and they publish more than 10 magazines currently. And he has been selected as one among the 50 students out of 1,000 applications that go out towards getting this position of student journalist. And under this role, he has developed a number of stories on space, technology and space tech. He has completed his master's in physics from New College, Chennai and bachelor's in physics from New College, Chennai. I welcome Mr. Rifat Shahrukh today evening, and we are looking forward to a very interesting presentation today. Thank you.
ஹலோ கைஸ், எல்லாருக்கும் வணக்கம். ஸோ நான் பேசுறது எல்லாருக்கும் நல்லா கேட்குதுன்னு நான் நினைக்கிறேன். ஸோ லெட்ஸ் கண்டினியூ டு தி. தேங்க்யூ ஸோ மச் டு டெஃப் ஒய் ஃபார் இந்த ப்ரோக்ராம்க்கு என்னை இன்வைட் பண்ணதுக்கு. ரொம்ப ரொம்ப ஹாப்பியா இருக்கு இன்னைக்கு இவங்க கூட எல்லாம் கனெக்ட் பண்றதுக்கு. ஸோ லெட்ஸ் கெட் ஸ்ட்ரைட் இன்டு தி டாபிக். ஸோ இன்னைக்கு வந்து பாத்தீங்கன்னா லைக் ஆல்ரெடி சார் வந்து என்னை பத்தி நாங்க என்ன பண்ணிட்டு இருக்கோம் அப்படின்லாம் வந்து சொன்னாரு. இன்னைக்கு நம்ம வந்து உங்களோட சேட்டலைட் எப்படி நீங்களே வந்து ஸ்டூடெண்ட்ஸ் பண்ணி அதை வந்து ஸ்பேஸ்ல லான்ச் பண்ணலாம் அப்படின்றத பத்தி தான் பார்க்க போறோம். அதுக்கு முன்னாடி as you guys all know, I'm Rifat Shahrukh and I'm the Chief Technology Officer of Space India. நாங்க வந்து பாத்தீங்கன்னா உலகத்திலேயே லைட்டஸ்ட் சேட்டலைட் கலாம் சாட் அப்படின்ற ஒரு சேட்டலைட்டை வந்து 2017 பில்ட் பண்ணி நாசா மூலயமா அந்த ஸ்பேஸ்க்கு வந்து லான்ச் பண்ணினோம். அதுக்கப்புறம் வந்து பாத்தீங்கன்னா 2 சேட்டலைட்ஸ், பெரிய சேட்டலைட்ஸ், கியூப் சேட்டலைட்ஸ்னு சொல்லுவாங்க, அதை வந்து பில்ட் பண்ணி இஸ்ரோ மூலயமா ஸ்பேஸ்க்கு வந்து லான்ச் பண்ணினோம். ஸோ இதெல்லாம் எதுக்கு பண்ணினோம், இதனால என்ன யூஸ், ஸ்பேஸ்னால என்ன யூஸ், இதெல்லாம் வந்து பிஃபோர் வி கெட் டு நோ அபவுட் சார், லெட்ஸ் சி என்ன மாதிரி லைக் ப்ரோக்ராம்ஸ் வி ஹவ் டெவலப்ட் சோ ஃபார் அப்படின்றத வந்து வி வில் ஹேவ் அ லுக். So I just like to share the video of our journey. Like Space Kids India is a 10-year-old organization. We are one of the oldest aerospace organization in India. So one of the oldest private aerospace organization in India. Okay, so we have developed a lot of programs over recent times. Developing satellites, small satellites, rockets, and everything. So before getting into the topic and knowing about how to build your own satellite and everything, let me share this small video of our journey and what we have did so far in the past 10 years. Let me share my screen with you guys.
So yeah, this is our journey for past 10 years. So we all started as like our company started as the ambassador, as an ambassador for Indian space program in NASA. So basically, in 2010, NASA gave ambassadorship to our organization, so we can take children from India to NASA to train them in different, aspects of aerospace education. But at that time only, we got the idea, like, why we should take always students from America and train them there. Why can't we create such facilities here in India? So with that thought only, we started this organization back in 2010. Before that, getting into all the excitement of building your own satellite and spacecraft, I'll just give you a small overview about my life and how I got how I got into space exploration and how we built the world's largest satellite and everything. So I was born in a very small village called Palapati, in Tamil Nadu. We don't even have a proper internet connection there, before a few years. So I was born there. My dad was actually a scientist. He was an electronics and communication engineer. But sadly, he wasn't there for me to like to guide me because he passed away when I was around 9 years old. But he was the one who initially got this interest. From him only I got this interest because he's a huge space freak. We used to watch all the launches of Apollo mission, the moon mission and everything. So at that time only I got this interest of getting into space exploration. Like I wanted to get into space industry and do some research. But we all wanted to become an astronaut when we were kids, right? Most of the people here we might have wanted to become astronauts and do a lot of cool things. It was around I was around 7 years old. I was watching TV with my dad, and India's GSLV Mark II rocket was getting launched that day, and it was the first time India was using cryogenic engine, which is basically like a liquid hydrogen and liquid oxygen engine to launch the rocket. So it was very, like a very big thing. All the news were covering about that. Me and my dad was watching that. So at that time, I was asking, what is this thing? What it does and everything. We were very excited, but the rocket launch was failed. After a minute after the launch, the rocket just burst into flames. So the rocket was failed. I was very disappointed. My dad was very disappointed. I was asking him why ISRO scientists were not able to fix it. It should be a very easy thing for them, right? So at that moment, my dad told it's very hard. Space is very hard. So you can only understand that if you become a scientist. So at that moment, I put a self goal inside me, that I want to become a space scientist. But if I say, from I was just around 7 years old. So if I say, from that time itself, I'm working hard to, become a space scientist, it would be not true because we, I was a kid at the time. I didn't took it very seriously. But it brought me the interest of becoming a space scientist, but I didn't have any clear view of becoming a space scientist. So, what we think usually, if you want to become a space scientist, you have to study in a very good university like IIT, and you have to finish your master's and get into ISRO or NASA and do space research. That is the typical thinking we have, right? But a very cool thing happened when I was in, ninth standard. So a lot of things happened. I learned. I was a very like a freak about technology. I love technology and I wanted to always create new things. So I learned a lot of programming languages. I started programming computers when I was around 5 years old. From my dad I learned that, and I got into a lot of electronics and a lot of other things, robotics and everything. I was doing a lot of other things. I was winning awards, state level awards, and everything for science invention and everything. But my interest came back to space exploration when I was in ninth standard. So there is a Tamil movie called Nanban. Okay, so in that movie, the hero flies a quadcopter. So I was watching that movie. So I wanted to build it. I wanted to build one. So I googled for quadcopter, and I was studying about aerodynamics of quadcopter in NASA's website. Okay, I was studying about that. And in NASA's website, inside, there was one, window telling about CubeSat. Okay, CubeSat. I was like, what is a CubeSat? We know satellite. We know satellite. Like we see satellites in TV during the launch of ISRO, NASA, and everything. Very, very big thing, like as big as like few cars, like as big as a room. Covered in gold color. Material. It's not that. Many people think it's a gold color foil cover, but it's not that. I'll tell what is that. But it will be, in gold color, very big. It will go to space, do a lot of research for monitoring weather, communication, and everything. So that is the perception I also had. Satellites are very big. Okay, you can only build it after joining ISRO or NASA, and that's pretty much it. Okay? I was concentrating. I should focus on my study and get into ISRO or NASA. So that is what the typical thinking we are having about satellites as well. But that one incident, when I was in NASA website, it was showing me something as CubeSat. So I clicked that. So what is CubeSat? Inside I went and I saw for the first time in my life something called Nano Satellites. I was amazed. What are nano satellites? We know nano is small, but how small this is. I kept on reading and I realized nano satellites are satellites which are weighing between 1 kg to 10 kg and looking as big as a shoebox. I was like, wow, that's amazing. That's a very small size for a satellite to be. We usually think, satellites are that big. How they got the size to, this small? For example, one CubeSat means it is 10 into 10 into 10 centimeter. You can build satellite as big as just a small Rubik's cube. So I was wondering, what is this? How they are doing? And then to my next surprise, students are building those satellites. Universities, colleges in Europe, US, they are building the satellite. I was like, oh, wow, students are building the satellite. I thought, I need to join ISRO to build satellites. But here, students are building the satellite. What all this is? So I went on searching more about this. And then I found there is a whole new industry called nano satellites. So for you guys, nano satellites are basically satellites weighing between 1 kg to 10 kg. And if the satellite is less than 1 kg, it is called pico satellites. We have a lot of classifications like that: pico satellite, femto satellite, like that. Basically, satellites less than 10 kg are considered as nano satellite. I was like, wow, how amazing this! But how can you shrink that size and how it will be useful? At the end of the day, the space exploration should be useful for the common people, and the space exploration should be useful for the goodness of Earth and making Earth a better place. So how these things were possible? So a simple logic. Computers, computers used to be as big as a house, as big as a room, like few decades ago. Now our mobile phone is doing all the tasks of a computer. In fact, it is much powerful than the first computer I had. A man landed on the moon with just 4 KB of RAM. The computer they used for controlling the spacecraft which landed on the moon, it was just having 4 KB of RAM. Now we are having gigabits of RAM. So over the time, the technology has reduced the size of electronics. We have came up with latest microprocessors, latest chips and everything. It has reduced the size of electronics. It has reduced the size of a computer. So what are satellites? Satellites are basically flying computers with sensors attached to them, so they can find different things. So nothing more than that. Satellites are basically a flying computer with solar panels to generate power and a certain type of sensor which will connect a certain type of data, and that will send back the collected data back to them. So when computers can become smaller, obviously satellites can become smaller. That is the concept. So in late 90s, a university professor in California Polytechnic, there is an institute called California Polytechnic in USA. So he is the one who came up with this concept of CubeSats, 10 into 10 into 10 centimeter satellites, very small and compact, standardized, so you can easily integrate and launch it. So they got all the small microcontrollers, sensors, and everything, and they have did it successfully and become very popular. Now the second point, why it is very popular with the students? Why students need to build satellites? For example, you want to become a robotics engineer, you can learn about robotics by building small robots. If you want to become an electronics engineer, you can do a lot of electronics project and you can learn about the electronics. But if you want to become a space scientist or a space engineer, there is no platform available for having real-time learning experience, how the space systems work, how to like to gain the experience of doing a real space project. If you are directly getting into employment of building a satellite, and if you go there with just your degree, it won't be useful. You won't be able to do anything. So to train you with real space systems, these nano satellites were very helpful. They can mimic what those bigger satellites can do. But the bigger satellite can take a better picture, but it will take pictures with a not that great, but still the principle, the basic principle behind clicking the picture and sending that back to Earth is seen. The programmers are there, computers are there, cameras there, you have to program it, use the communication system and transmit it to the principle, the basic principle is same for both the bigger satellite and smaller satellite. So US and European universities use this nano satellite concept as a great platform to train their students into real-time space exploration. So once they become professionals, they will build bigger and better satellites. But not just that, it is also a big interesting factor. You can do one thing only after you know that thing exists. You can only learn coding only after you learn that coding exists. So these kind of things, nano satellites also give spread interest among the students. It will inspire the students to get into space industry. So basically, Western countries were using this to attract more students, more research professionals into aerospace sector. This is how initially nano satellites got started. Basically, an educational tool and a research tool. For example, you are developing a new type of solar panel. You don't need to put that solar panel in a bigger satellite and risk a lot of money. Whether it will work or not, you don't know. But you can develop a smaller version of the same solar panel and put that in a small satellite and launch it into the space and test how it is working. And after demonstrating it, you can use it in a bigger satellite. So this is second type of the use for the nano satellite. So basically, only for educational and research purposes, initially nano satellites, they were using in late 90s and early 2000s. But then the time came, like in 2010 and late, 2015. In last 10 years, the technology grew so faster that 108 megapixel camera became very small. Our phones are having DSLR quality cameras. So the technology was going very fast. What happened is these nano satellites started replacing the actual satellites. Now the electronics become even smaller, that you don't just need the nano satellites for educational purposes, but real satellites, for example, monitoring hurricanes, providing communications from one country to another country, monitoring the resources, remote sensing. For all these purposes, the sensors became so small that you can put it in a 10 kg or like 20 kg package. So the satellites start to become smaller and smaller. Now it become more than $1 billion industry. There is a company called Planet Lab, which is, having more than 100 satellites in space to capture the 24x7, like 24x7 global map, like in real time, surveillance of the Earth. If you're building a one bigger satellite, it will cost hundreds of crores, and at any given time, the satellite can only focus certain part of Earth. For example, a satellite in low Earth orbit, it will take 14 days to scan entire Earth. Now this Planet Labs is having nano satellites, like hundreds of nano satellites covering the Earth. So at any moment, like 24x7, you can take picture of any point on Earth live. which means global coverage, so you can monitor the borders in a better position for to avoid terrorism. You can capture resources better. You can track the storms, hurricanes, and everything real time, so you can save a lot of lives and become a huge multi-billion-dollar market. And for communication, the modems and transponders become very small. Like, for example, the Starlink, right? Elon Musk is coming up with a program called Starlink, which is providing global connectivity around the earth, even in every all the places, like even in remote places they are providing. But if they did that project like 10 years or 20 years back, each satellite will be around 1,500 or 2,000 kgs. Now they are using this small satellite. Nano satellite is less than 10 kg. Small satellites are satellites less than 100 kg. Uh, Sorry, micro satellites are less than 100 kg. So these Starlink satellites are now weighing around 250 kg. From 2000 kg scale, now they are just 250 kg. In future, it will become even lesser than 100 kg. So things are becoming smaller and smaller. So even for real-time business applications, nano satellites are becoming useful. Lots and lots of companies, even Airtel, Airtel, which is a very big telecom operator in India, has invested in nano satellites to provide communications using nano satellite. So it's become a like just for instead of just education and research, it now become a multi-billion-dollar worth commercial sector for providing various services from space using nano satellites. So that is how the industry has become so far and developed in the past 20 years. Okay, this is how nano satellites has become very useful uh, in the last 2 decades. So now, what we are doing in this, what we Space Kids India is doing in this market. Okay. Initially, when I was telling, I was continuously talking about USA and Europe. So these technologies become predominantly useful for them, but it was not widespread to other parts of the nation. For countries like in India, for example, in Europe, one particular university has developed more than 10 satellites in the last few years, and they have those 10 satellites in orbit. But in India, the entire nation together itself, with all universities combined, we are only having 10 satellites. So that is the difference we are having between places like India and other countries. The development was not happening in other parts of the world, like in Gulf region, in Africa, in East Asia, India, like these places. The space boom and space development was not happening because it's very expensive. Even though I'm telling nano satellites are very economical, they are not truly economical from our point of view. For example, developing a bigger satellite like a 2000 or 3000 kg satellite plus satellite is costing you, say, 1000 crores. I'm talking in rupees, 1000 crores. Or let's talk in US dollars so you all can easily understand. Let's assume like it's costing $100 million to develop a bigger satellite. For developing a nano satellite of 1 kg, it will cost you $100,000. $100,000 means it is like around 70 to 80 lakhs for just 1 kg satellite. That is very, very expensive for Indian universities and universities in other countries. So if an Indian student or an African student want to have the same experience as an American or European student of building a satellite, for them, 1 crore or 2 crore rupees is very easy, where universities can afford. For them, it means affordable. For Indians, 1 crore or 2 crore for a developing, like a Rubik's Cube size satellite and launching it, people will feel it is very expensive. They will. It is not economical for us. It is not economical for people in this region. So that is where we started. We looked at the industry and we thought it can be made even more economical, right? India, China, these are the manufacturing hub. So when you mass produce something, it will get cheaper. So we thought we will create indigenous satellite components here in India. So that is why we started the research and we started developing our own satellite, the communication systems, structures, and everything. We started developing here in India indigenously to reduce the cost, so we can, from for a mission which is costing around 1 crore, we can reduce the price to 50 lakhs. It is around 50 percentage reduction in the cost and make it even more economical so students can be part of this. And another problem, faced in the space industry is things are very advanced. Like, if you want to buy a transponder, if you want to buy an onboard computer for a satellite, things are very advanced. When you go and want to buy the components to build your satellite, they are very advanced for, different industrial purposes. But for students to learn, you don't need that much advanced level. I'm not going to tell, we are also coming up with satellites just for, around 25 lakhs, 30 lakhs. Students can, build a small satellite, launch it to the space and learn so they can become better space engineers in the future. Universities can do this program. Already we have signed with a lot of universities who are conducting these programs. But the thing is, universities don't need to buy advanced components to build satellite work proof. This is just for learning, right? This is for learning and make better things in the future. So we came up with the satellite parks which are optimized exclusively for educational and research purposes. So that is how we were able to reduce the costs which are affordable for the students. So how we started in 2015, we launched our first balloon satellite. Balloon satellite means they are prototype satellites. You'll make a prototype of a satellite and you will launch that into space, called near space. Space starts about 100 kilometers, 100 kilometers from the sea level. At that altitude, the space starts. But instead of going there, you'll go to an altitude of around 30 kilometers, 30 to 35 kilometers, where the atmospheric characteristics are similar to space, almost like, 90% similar to space, almost near vacuum, very cold. So you can test all your components. So we started with that in 2015. You might have seen in our video, we are launching a lot of balloons, right? So those are called NSLV, Near Space Launch Vehicle. We have provided that kind of launch to many universities and schools so they can have that learning experience of building and launching a real satellite. So after that, in 2017, in 2016, actually, we built a 1 kg satellite. At that time, we didn't have this much knowledge that, like satellites are very expensive to launch. At that moment, we built a 1 kg satellite and we were looking for rocket launch providers. At that time only, we realized it cost around, $150,000 to launch 1 kg of payload into space, which is around 1 crore rupees. So the entire mission can cost you around 2 crores. At that time only we realized it's very expensive for us. So we were very sad, we were very sad and we were like, we were very crazy about space. Like, we wanted to do something in space and, make space more accessible and affordable for everyone. And get that type of revolution which happened in USA here to India and other countries. So we were thinking how we can make it even more economical. So we were having gulab jamun one day. We were like, okay, at that day, particularly that one day, we came to know about this pricing and everything. We were very sad and we were like, okay, to chill, to relax, let's go and eat something. So we will get some idea. Okay. So we were, having gulab jamun one day. I was about to take the gulab jamun and put that into my mouth. So at that time only I thought, see, a satellite used to be as big as a room. Now it is as small as a shoebox. If that kind of transformation is possible, then why can't we make the shoebox size satellite into a size of a gulab jamun? From 1 kg or 10 kg to just 100 grams. We will make it just 100 grams. So it will become even more economical and affordable. So we can launch a satellite, right? So we can make it more economical and affordable so everyone can be part of it. So it was at that time we felt crazy, but 1 week after that, NASA announced a competition called, there was an organization called iDoodle Learning Inc. They are like in collaboration with NASA, they announced this competition called Cubes in Space. So it is basically, they'll give you a slot of 4 into 4 into 4 centimeter cube. So that is the size they will give you. And your mass limitation is 64 grams. So in that size and weight, you have to build something which is useful for space. It can be a computer, it can be a sensor, or anything. You have to do it, and it will be useful for the future of space exploration. But we thought in that size, why don't we fit the entire satellite inside, and we will get a launch opportunity. So in that competition, they will select top applicants, and the winners will get an opportunity in a suborbital flight in a NASA rocket for free. So I was like, that is a wonderful opportunity. We should grab it. So we wrote the application. Around 64 countries participated. More than like thousands of students participated. We were like, yeah, let's hope. Let's give the proposal. We'll see how we are going to, do this thing. Thank God, that year our proposal got selected and we got a free launch from NASA on board that NASA rocket. It was one of the amazing days of our life. So we built a 64-gram satellite and we named it as Kalam sir because we all love, Dr. Kalam sir. He's like one of the my favorite person, an inspiring person. So to honor him, we named our satellite called Kalam sir and we launched it successfully. So after that, we kept on growing. We started building bigger and better satellites. We launched two more satellites in collaboration with ISRO. We built a 1 kg satellite and then a 3 kg satellite. So you may be asking, what are the purposes of this satellite? So for the Kalam set, the 64-gram satellite, the main purpose was the material science. For example, a satellite needs to have a body, right? It needs to have a structure. So whenever you need to manufacture something, if it is a steel or an aluminium, you can easily do milling, or you can easily mold, weld it, do something and develop the structure. But we wanted to reduce the size, so not just the size, reduce the mass, very importantly. So we wanted to use carbon fiber polymer for that. But to people, all your engineers, you will be aware of this thing. Carbon fiber is basically a cloth. It's a cloth. So to make molding out of it, you need a vacuum chamber. You need to have high temperature vacuum chamber where you need to have mold, and making molds are very expensive, and you need to cover the fiber around the mold and vacuum seal it and bake it in the oven for long time. It is a very complex process and it costs like lakhs, not if not crores. So it's very expensive process. And in fact, like if you are building a car, you will be producing like tens of thousands of cars or even lakhs of cars. So in mass production, this making die and everything is feasible. But in satellite, every iteration, every next satellite will have something better and something, optimized. So you cannot like standardize the structures like everything. So you need to like every design is unique. So we wanted to 3D print it. 3D printing is a beautiful concept that every time you have a design, you can print it. But 3D printing carbon fiber is not possible. Like carbon fiber is basically a thread woven into a cloth. So we there are materials available called carbon fiber polymer, which is basically carbon fiber mixed with some kind of few kinds of plastics. So this is called carbon fiber infused polymers. So we chose that material which is 3D printable, and we 3D printed the entire structure of the satellite. So the CalamSat's main goal was to test how this 3D printed structure is performing during the launch environment and in space. Because during the launch, you will face massive vibration, massive shocks up to 20 G force. So the structure need to be very strong for that, and it should absorb all those things. And it should not break. So that was the main goal, and we successfully developed that. And it also measured the radiation, the amount of radiation in space environment. So it was the purpose of the CalamSat. The recent satellite, a 3 kg satellite we developed called Satish Dhawan satellite, which is basically a communication satellite, IoT communication satellite. For example, you are having some sensor in the middle of the ocean which detects tsunami, or you're having some kind of sensor in petroleum, factory which is in the middle of the desert, and you need to send the data for processing, and you need to command those, control centers which are in remote places. You need to have in those places we don't have traditional, internet or in traditional mobile communication. So in those places, we are planning to provide communication using our satellite from space. So that is a satellite we recently developed. So like this, we are developing a lot of different satellites, but not just these satellites. We are developing something called satellite platform. Okay, basically, it's like a car. Okay, Tata Motors manufactures a car. You can buy it and use it for different purposes. You know, a Ola or Uber can buy it and make it a taxi. You can buy it and convert it to your own car, or you can rent it. A car can be manufactured and you can add different things to it and use it for different applications. And that is what we are doing in space. We are manufacturing the satellite platform, and other industries can buy the platform from us and add their own sensors. If they want to do remote sensing, they can add camera. If they want to, measure about the radiation, they can add that sensor, radiation sensor. These things are called as payload. Payload means the sensor which gives the application for the satellite. The remaining platform is the structure, onboard computer, transponder, communication system, power system, solar panels, these systems remains the same for all the satellites. Only the sensor gets replaced for each and every mission. So, different kind of applications can be given. So what we did is, so we developed this basic structure, and then we mass manufacture it in a production scale. In production scale, you can reduce the uh, economics. You can reduce the price of the systems. So you can just add a sensor, you can add something, and you can just launch it into space. And that is what we are doing right now with our new satellite structures, and we have successfully demonstrated it in space in like last February, and it was a massively successful. And that is what we are concentrating right now. I'll in the end of the webinar, I will play a small video about our recent launch we did back in February. Now coming to the point, how you guys can build the satellite. See, I personally feel, and our company organization feel that there are robotic classes, there are computer science classes, maths classes, but there is no like class or a course available for students to learn about spacecraft, build something in real, and launch that, not just building but launch that also into space. Not everybody is having opportunity to participate in NASA competition and get a free launch to the space. So that's why we invented this new program called FunSat. So this is basically a small spacecraft. We, designed and put that in a single board, and it just weighs 7 grams. It just weighs 7 grams. It has 10 different sensors. It can monitor temperature. It can monitor pressure levels, like acceleration, gyroscoping activities, lot of things. This thing can, detect. So what we are doing is we announced the spacecraft program where students can get enrolled into this program, and they will go through a junior diploma course, like around like 15-hour course, and they can learn about all this spacecraft, what is space and everything, and then they will build the spacecraft and they will program the spacecraft, and after that is done, they will send this to us. They will send this to us, and we will launch that into space on our own rocket, which we are building. And once it goes to space, it will collect the data and send the data back to us, which will be shared with the students, and we will tell them what you can do with the data and how it will be useful for them. The main focus here, it is going to be the first step into space exploration. If your kid wants to, become a space scientist or an astronaut, this will be the first learning experience, like real-time learning experience. Because after launching all these satellites, we get like emails and calls from all the students. They also want to do something similar, but it's very expensive. Like it will cost like 5 lakhs, 6 lakhs, or something like that. We wanted to do that very economical, so every student can afford it. So this program, including the launch to the space, is just around 25,000 rupees, around $350, which is almost as expensive as a mobile phone. So that is the one of the coolest thing we have did so far. And as of now, it is available only in India. We are doing our first launch in uh, coming December. Coming December, we are doing the first launch. Already students started registering for it and buying this. And very soon we are planning to, like expand to the GCC region. So stay tuned. Hopefully, by next year you will be able to get this. But this year also we are planning only few selected countries. Other countries we are planning to expand. More details we will announce it very soon. You can learn more about this program, about how to launch your own satellite at www.spacekidsindia.in/funsat. The organizers will give you the more, the forum will give you the details. TEF, you can get more details from TEF, or you can just Google it. You can go to Space Kids India, our website, and inside that, there will be like a pop-up. You'll get a pop-up, and you can just click it, and you'll get more info. So this small board has around 10 sensors. It has a temperature sensor, humidity sensor, pressure and gas sensor. It also has accelerometer, gyroscope, magnetometer, which will be useful to monitor, during the launch, how much acceleration you are getting, what is the gyroscopic activity, what are the magnetic levels in the Earth's magnetosphere, those data. And we have IR sensor, which will basically measure the amount of IR radiation in the space. So we have a lot of sensors like that. Students can program it to, collect different data, and they can receive it directly from the space using our rocket. That is what we are planning. So we are making space more affordable and accessible. So even students from school can access it. For example, one of the youngest student who bought this kit is from around fourth standard. Okay, so there is no age limit. Students from fourth standard can go into space and do space exploration, and that is what we are coming up with. We are opening the space industry to everyone. So even students, researchers, hobbyists, anyone can, be part of space industry and do real space exploration, not just hobby like, building a model or building something, but real spacecraft and launching that into real space on a real rocket. So that is what we want to do, to give them the real time experience. So I hope this, might be, useful for you guys. I hope you might have learned about what are the nano satellite, what are the exploration, and how soon, you can also build one. I told you about our recent satellite launch, right? I'll play that video, and from there we will finish the session. Just give me a second. I will share my screen. I'm sharing the screen. I shared audio as well. But last time. So that's the wrap for the session. We are very happy that we are making space accessible for everyone, and that is our goal, to make it easy and affordable, and making space, easy to reach. And thank you so much for the TEF forum for this amazing amazing opportunity, and thank you so much for Mr. Ibrahim, who is my well-wisher and my brother from other mother. Like, he's the one who arranged this webinar. We are doing a lot of programs. We are also having a forum called Young Minds with Mr. Ibrahim, and we are doing a lot of activities over there. It has a Facebook group. You can go and check out there. You can check our website and everything. Thank you so much, and we are looking forward to have a lot of space scientists and students from Kuwait get into this kind of new activities. Thank you so much, guys. See you.
Thank you so much, Mr. Rifat. It was really interesting. We have invited a lot of students for this event. So for sure, they are going to ask you some questions. So please stay with us
Sure.
for some time so that you can
Yeah, I
clarify.
will. Sure. Will do that.
Any questions from the students? I've seen somebody raised hand. Yes, Miss Shaurya. Anybody having questions? Yes. Miss Uma Maheshwari,
Yeah.
can you please unmute and ask your question?
I think already there is one question in the chat
Yes.
box called how long does it take to complete the full nano satellite? It depends upon the mission, like from 6 months to 1 year, depending upon the complexity, it takes time. Typically around 3 to 6 months. But we have also built a satellite under 6 days, which is a very important mission we did with this book. So even under a week, you can build the satellite.
Fine. See, yes, there is one more question. How can we control satellites? Miss Shaurya.
Yeah. Controlling the satellite in the sense there are like different types of control. One is giving it commands like take picture, charge the battery, putting it in power saving mode. Yes, like in your mobile phone, even satellites has power saving mode and everything. Like giving commands. And another type of control is controlling the satellite literally. For example, rotate in this direction, rotate in that direction. Like you can give commands like. So basically, you will send the command to the satellite using radio waves, and then the satellite will do the action. If it is related to moving in different directions, satellites have small thrusters, which are basically small rocket engines, which will fire, very precisely to move the satellites. The nano satellites which we develop, they don't have these small engines enough because it's very like complicated with them. But what we do is we have reaction wheel, something called reaction wheel and magnet torques. You can study more about that, which are basically magnet torque means which is basically a coil, electromagnetic coil, and we will when we power the coil, it will produce electromagnetic field. And Earth also has electromagnetic field, right? So that electromagnetic field and satellites electromagnetic field, they like reflect each other. Like depending on the activity, the satellite will start to move. For example, North Pole and South Pole is here. North Pole is on the top, South Pole is on the bottom, and my satellite is here. I want to align the North Pole and South Pole of my satellite to the Earth's, poles. I will just power on my satellite's electromagnetic coil, and it will automatically get aligned due to the electromagnetic waves, just like magnets. So it's I'm just telling like very simply, but it's very complex engineering problem. Totally, control engineers will be aware of it. Control systems, it's full of control systems. But this is basically how we control a satellite.
Yes, thank you. Again, one more question from Mr. Revan. How can it balance itself in the orbit?
Sorry, I didn't get you.
How can it balance itself in the orbit?
Balancing in the orbit. Yeah, this is a good question actually. There is nothing but balancing in the orbit. Once you are in orbit, you're going to fly. You're not going to fall. That's because many people think, why you are not falling from space. Many people think Earth is having gravity only on the surface, and when you go to space, Earth's gravitational pull is no more. So you are like floating in space. But that is actually a wrong answer. Earth's gravitational pull is very big. Like the Earth's, effect on other bodies. Effect on other bodies is very far. That why the moon is not going somewhere? Why it is always rotating around the Earth? Because Earth's gravity's influence is, beyond the moon. Even beyond the moon, Earth's gravitational pull can be felt. What actually happening, like in space, and how the satellites are not falling is, I'll just try to tell it as simple as possible. Okay, you're throwing a ball. Okay, you're throwing a ball, and this ball, you know, goes straightly for some time and then falls down due to gravity. Okay, this is basically a parabola. So when you throw it faster and faster, the ball goes far and far. And then finally, when you reach certain velocity, the ball, the parabola of the ball's trajectory will become so bigger that it's bigger than the Earth's diameter. So the ball will go up and start to fall down, but it will miss the Earth and it will go down. Again, it will start falling towards the Earth and it will miss the Earth. So what astronauts are actually doing in space is they are continuously falling towards Earth, but they are missing the Earth. So that is what happened. They are in gravity. There is no such thing called zero gravity. That's why in every NASA document, mostly they use the word microgravity, not the zero gravity, because in space, gravity is still there. And that is the reason the satellite is spinning around the Earth instead of going somewhere else in a random direction. Because Earth's gravity is pulling towards it, and that's why it's properly, circulating the Earth. Okay, you can know more about it from Newton's cannonball experiment. There is a Wikipedia article, Newton's cannonball experiment. You can learn more about this, and we will be also like teaching more about this in our programs in the coming days.
There is one more question from same Raymond. Will it overheat while the thrusters start while launching?
Sorry, your voice is actually a little bit breaking. Can you please?
Will it overheat while the thrusters start while launching?
Yeah. It will not overheat because they will do all the simulations and everything properly, and they will put proper protection. And actually, the gold color thing you saw on satellites, right? That is called, multi-layer insulation, ML they call it. So that basically a thermal protection system which will protect the satellite from overheating.
Thank you. And there is one more question from Mr. Roshan. Sir, could you please put the links for the websites you mentioned in the chat box? They're asking for the website, your SpaceKit website. Also, can you please tell briefly about the course? You said something about 15 hours course, right?
Yes. So basically, like there are a lot of courses available for the space. Like you just learn about space, you learn about orbit or satellite or something. But we wanted to do something hands-on for the students. It is not just learning the course, but after the course, what if you can build your own spacecraft and also launch that into space? So that is the program called the FunSat. This is basically the FunSat spacecraft board. So once you join this program, FunSat program, we will send a kit to you, basically a kit which contains all the parts for making this spacecraft. And there'll be 15-hour course on in that you'll learn about space science, satellite technology, and everything. And after that, you'll build the spacecraft, you'll program the spacecraft and send that back to us. And we will launch this to space on our rocket. And it will send the data which will be shared with the students. And we'll teach them how they can use the data for different purposes. So that is a very short brief about this program.
How long
they can know
course is?
Sorry?
How long this course is about for learning?
It is around 15 hours.
15 hours. So within 15 hours, they can learn. Okay.
Yeah. So basically, it's only available in India as of now because sending this kit to other countries, it requires a lot of regulations. It needs a lot of support and everything. So soon we are planning to bring it to other countries as well, particularly GCC region very soon.
Sure. And where do you store electricity in satellites? There is one more question from Mr. Nitin Krish.
Yeah, basically in satellites we use lithium-ion batteries, which is similar to the one we are using in mobile phones, but manufactured in more precise and controlled manner. So because lithium-ion batteries are very prone to burst into flames, so we take a lot of cautions for that. But basically we use lithium-ion batteries right now for our satellites.
Thank you. And there is one question from Mr. Abhi now. Before launching, are you doing any simulation for the
A
satellite?
lot of simulation, a lot of simulation. We use ANSYS, we use SolidWorks for the designing. Uh, Most predominantly we use ANSYS for all the mechanical simulation, and then we use Proteus for electronic simulation. Then MATLAB, a lot of tools are there. Then there is something called systems tool, STK. There's a software called STK, which is we use for simulating the orbit, how the satellite is going to be in the orbit, how it will at what altitude it will be. So a lot of simulation.
Thank you. And I think this is another good question. What is the average lifespan of these nano satellites?
It varies from mission to mission. Depending upon the mission, it changes. On average, educational missions, we put goal somewhere between 6 months to 1 year. And for mini nano satellites, it works somewhere between 2 to 5 years. But there are satellites which have worked even more successful, like even after 5 years. But the average time span is between 6 months to 2 years.
So after 6 months, it will be disabled. Is that?
Yeah, we will disable it. There are laws, international laws and regulations you should adhere to. So depending upon your mission, the International Telecommunication Union will give you the license for how long you can operate the satellite in space. So depending on that, even if the satellite in space, we will disable it.
Okay. And there is one more question. What made you develop the interest to pursue physics as a major out of all many other subjects? And as you might
That's a great question.
Some students dread for physics. How would you make them think positive about the subject to change their perspective about this subject?
Two answers for this. I love physics. I love physics because you take anything, civil engineering, electronic or electrical engineering, computers, everything at the end of the day comes to electrons, gates, transducers, and everything. And they are part of physics. So everything is part of physics. So the entire world is ruled by physics, I would say. So I just love physics, and that is the main reason. Because in engineering, you learn more about applications and everything. In physics, you learn even the core concepts. Even though in my role, my job, the thing I do is engineering. Like the solutions we are developing as a profession. If you look at me, the thing I'm doing is engineering. But to do this, to have the better and deeper understanding, physics helped me a lot. I always question a lot: why this? Why that? What is behind that? So physics helped me to explore that. And second reason is in India, because I don't think colleges are like teaching us enough to do the practical learning. And I would say in India, uh, colleges are not up to the mark. Learning there is not useful. I consider it is not useful for me. Like that is what Steve Jobs also said. I'm not like copying or anything, but when I compare like what I'm studying, is it really useful? The way I'm studying is not up to the mark. It's not useful for me. So I got a lot of offers from a lot of many top engineering colleges, but I denied that. I wantedly got into physics because particularly in India, I'm not sure about the Kuwait, but in India, doing engineering is more about doing homework. They will, push you with assignments. They will push you with exams. The actual engineering you're learning is very, very small. Okay, I want to learn engineering. I'm not going there to do assignment, writing tons of assignments. So I thought, okay, India is not the right place to, many universities. There are exceptional universities somewhere, but many universities are like that. So I didn't want to do engineering, pursue engineering at first. But while looking at physics, the amount of load I need to study is very less comparing to that. So I can utilize my time better in my laboratory. In our laboratory, I can do my own research and I can dedicate my time to learn what I love. So that is the second reason why I chose physics. So it is basically a shortcut, so I can do what I love and what I do better.
That's why we got a young scientist here.
Thank you so much.
And there is one more question from Mr. Mayuran Anbalagan. I remember you were saying about these 10 measurements, it can measure humidity as well. So I think that's why he's asking this question. How does space have humidity?
Yeah, the reason is space doesn't have humidity, and we want to tell the students via the practical exposure. Like, if you say space don't have humidity, they'll ask how this humidity is changing. So by putting a small humidity sensor, so when the rocket gets launched during the ground level, it will be somewhere between 8 to 93% or 98%, depending upon that particular day. So when they go higher and higher, the humidity will get reduced. And when they go into space, it will become almost zero because we don't know relative humidity inside the chamber. There might be possibilities for 1 or 2% of the humidity, but it will become almost near zero. So by using this data, we will teach students what is the relation between the altitude and humidity and how this is changing. So to teach students there is no humidity only, we are teaching humidity.
Okay. There's another question from Mr. Segu Yusuf. How do you decide the payloads? Of course, it is based on application. Could you please elaborate on payload design?
That is a very big topic, and it will happen for like a week or if not months deciding. But basically, depending upon your what you want to do. If you are a remote sensing company who want to take picture of in particular interval. Okay, what kind of picture you want? What is the wavelength? What is the resolution? Resolution in the sense we don't calculate resolution like 1024 into 780 pixels like we do for computer screen. Resolution in the sense when looking from space, how close the image looks. We have like 2 meter resolution, 5 meter resolution, sub-meter resolution. Sub-meter resolution means less than 1 meter resolution. So the image you are taking with the satellite will look like you are looking at 1 meter above the earth. It will be that close. Just like I'm sitting here. So from 2 meters, how the image will look, it will look like that when you're capturing the image from the satellite. There are spy satellites which, when you capture the image, you can even see number plate of the vehicle. That zooming it can do. So we will basically see what resolution you want and what kind of the end user are going to use. For example, like in Kuwait and other GCC region, there are a lot of petroleum wells. They use satellite data to see how the petroleum levels are changing over the time. So do you want to take pictures in morning or in night? In morning, there is light, you can take pictures. So in night, you don't have pictures. So you have to use something called, you have to use radars, radio frequency for taking images. So like that, there are thousands of different data points. You have to go through all of the thing. And it's all about the end user.
Sure.
Whether you're doing a small restaurant business or a small electronic business or space business, it is all about end user, what kind of needs they have. So like that, we have to do a lot of computation and we have to see what is the size, what is the budget. And from business side also, we need to see. For example, if you're running a company, what amount of funding you have? Do you have enough funding to launch a 100 kg satellite or 10 kg satellite? What best we can do with your budget? So it is both management and the thing. So that is why in space, many people think only aerospace engineers can, get into that. But in space, almost like 30 to 40% of the jobs are dominated by MBA and business weighted people because budgeting is very important. So you have to do a lot of calculations like this and finally come up with it.
And don't you think this, if everyone is going to launch satellites, nano satellites, don't you think this will become overcrowded? Like, what will be the privacy there? Because if you see in a lot of countries, they have even banned drone cameras. They cannot fly even drone cameras. So, what is the parameters you set for? What is the approval you get normally to parameter?
First of all, the spacecrafts we are launching for the students, they are not orbital, they are suborbital, which means they will go to space and will come back. So you're not creating any pollution because we are planning to do thousands of missions like this in the upcoming days. We don't want to litter space. So that is how we are avoiding. By doing, we will only go to orbit when required. If you can do the research in suborbital missions, we will go for suborbital missions. But apart from that, space junk is becoming a huge problem. For example, the amount of satellites we launched in last 10 years is equal to the amount of satellites we launched in last 1 year. So that much satellites, because not just the students belong to just less than 1%. The big corporations like Amazon is launching satellites, SpaceX is launching satellites. So thousands of satellites are being launched. So governments are taking this thing very seriously. There are UN, United Nations is having a separate a body called United Nations Office of Outer Space Affairs. So they are having a lot of regulations. For example, if you're launching a satellite, it is compulsory that you should deorbit it within 20 years. If you don't do that, there are a lot of fines will be imposed. And getting the license for building launching a satellite is harder than building the satellite. I know that thing because it will take around a year or two to get the licenses. Very hard process, multiple licenses
Lot
for
of
radio frequency. It is not just the satellite colliding. Radio frequencies are very delicate. Even if they are not colliding physically, they can interfere with each other, even if they are like hundreds of kilometers apart or tens of kilometers apart. So each frequency, like how spectrum allotment government is doing for mobile towers, same thing needs to be done for satellites in space, and they have to make sure not two satellites are using the same frequency at any time. Very complex process. Separate law bodies and legal bodies are there. They're doing it. Regarding the privacy, it's hard. Like it is very well known. Right from the 1960s, America is spying Russia, Russia is spying America. So space-based spying is becoming a very big concern and very big problem. And that's why countries like India are developing anti-satellite missiles. Like if you think that satellite is spying you, you can shoot on that satellite from above. But that is not a good practice. It will create a lot of other debris which will be dangerous for other missions. So in space, only the cooperation and peace is the answer. It is not place for doing a war or shooting down the satellite. So that is why all the countries are working together carefully and creating a lot of treaties. Like how we ban nuclear weapons with nuclear treaties. There are a lot of treaties are being produced for making space a better place, which can be used for a peaceful peace.
So how many nano satellites you put in a rocket normally? Do you have any?
So for the record is 114 satellites in the same rocket.
So all these
That's the maximum number.
Will float separate, or all these will be?
Yeah. No. They'll float separately. They will rotate the rocket little bit accordingly, and they will shoot down eject the satellite with different velocities. So they will do that calculation and make sure that not the satellites are collide. So
there is another question from Mr. Masa. He's asking about, does the nano satellite crash with other satellites?
Nano satellites, as of now, no. As of now, nothing like that happened because see, space is very big compared to the satellites are smaller than needles. So the chances are like 1 in 2 million, 1 in 10 million like that for the crashing. But we continuously monitor the satellites using ground-based radars, and if the collision is going to happen, if the satellite has inbuilt thrusters, we will use that to move. If it doesn't have inbuilt thrusters, then there are a lot of other aerodynamic ways to not aerodynamic, astrodynamic ways to move the satellites. So we do that action. And recently, NASA and ESA are developing basically space traffic lights. Like that kind of system is being developed, which will use artificial intelligence to monitor. For example, if a collision is going to happen after 10 days or 1 week, they can detect the previous itself using algorithms, and they can take required actions to avoid.
It's more required.
Yeah.
Kavin Murugan, how was satellites programmed with the help of computers? What is the program normally you use? Is software or?
Very simple. Like how you program, it's all about embedded systems. We use C, C++, MicroPython, Python. These are used for low-level microcontrollers. Then many satellites run Linux. For example, the recent Curiosity rover, which sent to Mars, and the helicopter Ingenuity, which was in Mars right now, it uses Linux-based systems. Okay, and then we also use real-time operating system, RTOS, which is very important. So it is basically like programming any other computer, but the stake is very high. If you make one error, it will cost in millions of dollars. Not like you can solve it. Even a missing column or missing comma can make the entire rocket crash. For example, there are scenarios in one mission. The programmer missed one semicolon, and the entire rocket burst into flames, and it was loss of around more than $100 million. So it is the biggest mistake. Once a semicolon gone, the entire rocket is gone. So we take a lot of standards. We follow lot of standards and protocols to avoid this.
You have any special software for this, or developed any software, or you are doing
No,
already
no,
the?
no. No. Like basically, the core language is same. C, C++, Python, that is same. But we modify it, according to our requirement. For example, there are a lot of authors for projects, but for the space and CubeSat application, we modify those projects and we create our own operating systems. For example, we at SK, we have our own copy of Authors, we have our own copy of Linux-based operating system. But we just basically inside we are running Ubuntu. We have ran Ubuntu in space. Arduino, many people are aware of Arduino. Students, they love Arduino. We have put Arduino in space. We have put Arduino in space. We have programmed it using Arduino. So the space, it is all about any tool can be used in space, but it is about wisely you are using it, how you are planning it, and how you are optimizing it.
And there is
For
another.
example, this board is powered by Arduino. This
Arduino,
board is
okay,
actually
Arduino board. Okay. There is one more question from Mr. Gautam. Normally, what is the temperature in space?
it differs like where you are. It's completely like space is very big. It can go as low as in -500, -300, or can go as high as like 260, 300 like that. But if you're asking about lower Earth orbit, where we have a lot of experience with our own satellite, it can go somewhere like -100 to +100. So that is the upper limit and lower limit, worst case scenario we have. But inside the readings we got from our satellite, outside surface will be very hot, but inside the temperature will be very less because there is no air or any medium to conduct temperature from one part to another part. There is no conduction, there is only convection happens. So the readings we got will be somewhere like -40 or -60 all the way to +60 or something like that.
So is it the same which you are showing the nano satellite? Is it the same will be sent to the space, or this is just a model of what you are showing?
The same.
So is it temperature resistant? Because you said
Yes.
-100. Okay, it just looks
Yes.
like a normal board. That's why I'm asking.
No. That is misconceptions people are having about the space industry. Any standard PCB can withstand like -40 or like +60. But the components we use in this board and the way we manufacture it, we make sure the lead and the paste we are using, or you don't believe there is a 1,500-page document available to follow standards about how to do soldering for space PCBs. So we need to follow that. So the components we are using are a little bit expensive.
It just
for example,
board inside a remote. If you open a TV remote, it just looks
yeah.
like
Yeah, it looks the same. It looks the
Yes.
same. Yeah, it looks the same. But the way you're manufacturing is different.
Thank you. And there is a question from Ms. Uditra Sivakumar. How many times will you recheck before launching a satellite?
Sorry, how many times?
How many times will you recheck? How many times you simulate?
So we have reviews called mission readiness review, MRR. We do that. So that is the master review we do. Each and every components as an individual component we need to test, and together we need to test. It comes under systems engineering, and my expertise is actually systems engineering. Uh, the things I do are mostly into communication, but here in the team, my role is fully systems engineering. So we do test components separately, then we connect it together and test it. So at least each component will be tested around 100 to 200 times. And as the overall system, the amount of tests we have done for the satellite will easily cross somewhere between 2,500 to 3,000 tests we will be doing. And after that, we need to do vibration testing, shock testing, thermovac testing. These things we need to do under a calibrated laboratory environment inside ISRO.
For each nano satellite you'll be doing, right?
Yes. And whenever we are building a nano satellite, we need to build two identical nano satellites. One will be launched and another will be kept in ground. So if some kind of problem happens in space, you can come up with a solution and test it in the ground system before sending that into the space-based system. So that is one of the practice we follow, and we have to do all the tests. If it is 2,500 test points, we have to do the same for this satellite and that satellite. So in a mission, the test can go like 5,000 plus tests we need to do.
There is one more question from Mr. Revant. How many satellites you have made? Which one was best among them?
Great question. We have made more than 16 missions so far. 12 balloon set missions, 2 suborbital missions, and 2 orbital missions. And my favorite mission so far is our latest satellite, the Satish Dhawan satellite, because it is one of the advanced satellites we have ever built so far, and it is 100%, almost 100% indigenously made. That each capacitor resistor design, the structure, the screw, everything, like we designed with our own hands. It took us 2 years, and it has reduced the cost of manufacturing satellites by 50%, which is a very huge mark in space. That is my favorite satellite, and we have a lot of fun. Because building a satellite is not just very scientific and technical thing. We have a lot of fun. The travel we do, whenever we open up conversations, it continues for us. Not just technically, but all the fun we had during the mission.
Nice. One more. The question from Mr. Gautam. Nano satellites or any satellites can hold heat or cold in the space. I think that is the same what we answered, what we discussed.
Same, yeah.
Yes. Another question from Mr. Mayuran Anbalagan. How do you know if the sensor has found anything?
Sorry, for?
How do you know if the sensor has found anything? So we'll be controlling from the ground, right?
Yes. Basically, sensors, we have automatic calibration on the ground, because when talking about sensor, calibration is important. So we do the calibration, during the in-flight environment, and there will be a lot of automation as well, right? Because we can control the satellite only when it is over India, and we will get the coverage over India only for 10 minutes and 2 times in a day. And rest of the times it will be flying all over other countries. Of course, we have ground stations in other countries as well, but in any particular point, the amount of connection you will get is very short time. So we automate a lot of things.
Thank you. And you need to excuse me, there are 15 more questions. I think you have time.
Sure, yeah, no problem.
Like lots of students, they are very much excited.
Sure. No issues.
And there is an interesting question from Mr. Darshan. Can we launch Nano Satellite with a helium balloon without government's authorization?
No, not at all. You will end up in jail mostly. Very big problem, because you are putting lives of many people at stake. Yes. Because aeroplanes will be flying. Just imagine it's getting stuck with aeroplane wing or engine. It will create a lot of problem. So you have to get permissions from at least 5 different authorities, 5 to 6 different authorities, depending upon the country.
Sure. There is one more question from Mr. A.R. Gautam. How does a satellite's period change with its altitude above the planet?
Yeah, that depends upon the orbital velocity. The more higher, in the altitude you go, the amount of gravitational pull you are getting gets reduced. It comes under Newton's inverse square law. Gravity depends upon the mass of the product of the masses and square of distance between them, which is basically the physics we studied back in 8th, 9th standard. So when the altitude increases, the gravity decreases. So the force you need to rotate, the amount of velocity you need to put will get reduced. So that is why in lower Earth orbit, the velocity will be somewhere lower Earth orbit, in a second, we will be traveling 7.5 kilometers. So in just 1 second, we will be traveling 7.5 kilometers. But as you're going higher, it will reduce to 6, 5, 4, 1, like that it gets reduced.
Yeah. And there's one more question from same Mr. Gautam. What is the purpose of a curved reflector on a satellite?
It's not just a curved reflector. Now the technology has improved a lot, and nowadays most of the satellites are using patch antennas. But when you are going for geostationary satellites, mostly those kind of satellites are the one which uses that dish, which is basically called a dish. So the thing we use is for focusing the radio signal. So which is basically a parabolic reflector. So you can steer the antennas and focus which country you want to provide service.
I think the next
reason is because, for example, if you are having license in India, just you are rotating your antenna a little bit, and you're providing, your radio frequency is falling on the surface of Pakistan, you may get fined.
Yes.
Okay, so there are a lot of problems with it. So
I think that is
here
what
again,
the next question is all about. Same from Mr. Gautam. Since one satellite can see half of the Earth, why do we need more than two satellites in a given network?
it is not one satellite can see half of Earth. It is almost, we need three satellites at least to cover entire Earth. If you are in a geostationary orbit, you need at least three satellites, okay, to cover entire thing. But it is only possible in geostationary, orbits, because you are like 36,000 kilometers far away. But when you are in low Earth orbit, you can only cover like, the surface of entire Tamil Nadu or Andhra Pradesh. Your footprint, we call it as footprint. It will be around like a diameter of 1,000 kilometers or something. The closer you are getting, your footprint will get smaller. So depending upon the altitude, the orbit you're in, the closer you are, the more satellites you need. The far you are, you need, less satellites you can. The minimum satellites you need is three satellites for providing global communication, except the pole region, North Pole and South Pole. You cannot cover it in geostationary. So they are having separate or type of orbits for providing communications. It's a bit risky, it's a bit risky in pole regions.
There is another question from Ms. Hanshika Sam. I think this is what we already discussed, but let me put this out. Also, as there is a lot of satellite launched to space, so if after some time it stops working, will they bring the satellite back to Earth? If not, does that mean there is trash in space?
Interesting question.
Yes.
I'm going to say nowadays, when the satellite flies in space, it's over. But do you know, like health insurance, we have insurance for satellites. All the satellites going to space should have insurance. So when your satellite flies, for the right reasons, you can claim the insurance for the company. But back in the days of space shuttle, they did very cool things. You might have heard about second-hand computers, second-hand cars, second-hand laptop. Do you believe there was second-hand satellites? Yes. Like in the 1990s, they launched one satellite and it went to space, and due to some problem, it stopped working. So they used to have space shuttle. Nowadays, our rockets are, just go and release it. But when space shuttle was active, it can hold satellite inside, put it in the orbit, and it can take satellites inside and come back to Earth. If the satellite just enters space, it will get burned due to the atmospheric friction. But space shuttle is designed to, go through the atmospheric friction. So one satellite they launched, it failed. So what they did is in the next mission, they launched new satellites, and after that, the bay was empty. So they chased that broken satellite. They took that inside. They closed the doors. They landed on it, and they took that to the company. They did service, they did servicing to the satellite. They fixed it, and another company, basically Star Communication, Star Network, right? They bought that satellite. They, launched it from China on a different rocket, and that is how one of the first Star movies and Star Network, all those channels got telecasted from the second-hand satellite.
Very nice, very nice. Next question from Ms. Shaurya. Can we send nano satellites to other planets or moon too?
Yeah, actually, NASA has already sent a couple of nano satellite CubeSats to Mars for data relay purposes. And next year, there are a bunch of nano satellites going to the moon, because NASA is planning to send humans again to the moon by 2024 or 2025 mostly. So for that, to conduct early studies, NASA is sending a couple of CubeSats to the moon.
Thank you. And there is one question from Mr. Jafarullah. How many types of satellites available?
That's a very generic question, I would say, but at least more than 100 types, considering all the different parameters. It is like pizza. You can customize as much as you want, infinity.
Okay. And one more question from Mr. Revant. What are the tests you will do?
Test means there are two types of testing. One is internal technical testing for the satellites, like how the computer is performing, sensor is performing. There are thousands of tests I told. So those are like one of the common types. The environmental testing, which means the rocket can survive the satellite can survive the rocket launch, because the rocket launch is going to be one of the hardest part uh, for a satellite, in its journey from Earth to space. Vibration will be high, shock will be high, noise levels will be high. So we will be doing something called environmental testing. So basically, vibration testing, shock testing, MEMC, electromagnetic interference and electromagnetic compatibility testing, and then thermovacuum testing. Thermovacuum testing is, like, I love the test because you just put it in a vacuum chamber and you will cycle it through different temperature, like from -100 to +100. You will switch rapidly and see how it is, enduring that, and you will just sit inside the facility peacefully looking at it. You'll have a lot of fun inside that lab. So I love that test.
Thank you. Next from Mr. Harshit. How long does it take to launch the rocket?
You won't believe it just takes around 2 to 3 minutes to reach space from ground. And the entire mission can be as long as just 18 minutes from the launch to space, like satellite release. It can be as low as just 18 minutes.
Thank you. Next from Mr. Arshad Basha. Does the Nano Satellite found a fault in space? Can we do service?
No, for nano satellites, with our current, rockets, we can't do. But types of problem. For example, if it is a software problem or a configuration problem, or like in program you made some error, there are possibilities you can completely wipe off the computer and reprogram it from the ground. So if it is a software configuration problem, you can do. But if it is a hardware related issue, nothing can do.
And there is another question from Mr. Darshan. Is Hohmann transfer possible in nano satellites?
No, because nano satellites are very small. They don't have that engines which are powerful enough in doing the transfer. So what they usually do is that will attach to the mothership. For example, if Chandrayaan's spacecraft is going to Moon or Mangalyaan is going to Mars, they will attach these nano satellites inside the mothership, Mangalyaan. So that Mangalyaan will do the Hohmann transfer and everything. And finally, after entering the orbit of Mars, using the mothership's engine, these nano satellites will get released. So that is how they do in India. Like countries like India, we don't have much powerful rockets. But for countries like USA, Russia, China or not, they have powerful rockets. So you don't basically need Hohmann transfer or like the multiple orbit tracing nanos. You can directly launch it. So in that case, in China recently, they launched not actually nano satellites around 10 kg. They launched it. The actual transfer was done by the mothership, but orbit capture, which means you'll reduce the velocity and capture the orbit around the planet, which was done by the nano satellite itself. But the entire transfer, course correction, and everything, you can't. Course correction can be done, but the transfer of orbits you can't do.
So you said that you will have a backup satellite in the ground space, right? You said one more model will be.
Yes.
There is one more question. Is the nano satellite placed in the geostationary orbit?
No, not yet. And we tried to do that last month. we are working on a proposal. It's supposed to launch last month, but due to some reason, it's not doing. But soon we will be the first one, most probably, to have a nano satellite in space.
All the best.
Thank you.
One more question. Will there be a time lag in the upcoming satellite-based internet connection?
It will be very, very, very small. You won't be able to notice it.
Thank you. One question from Mr. Sriram. What is the orbital height in which nanosatellites orbit?
Generally 500 kilometers. That is the most famous.
Okay. Next question from Mr. Khaira Fatima. After achieving and launching satellites, what next? Will these satellites have a direct influence in everyday life for common man?
Of course, yeah, you're right. In future, GPS is going to be replaced with nanosatellites. And right now, nanosatellites are helping in monitoring hurricanes, saving thousands of people's lives. It's being used in industry for various purposes. It may not directly impact common man's life, but indirectly, there are a lot of industries which are using, and the product those industries producing will impact the life of these people. So ultimately, nano satellites are making life on Earth a better one.
Thank you. Mr. Jaykumar is raising the question. Sir, can you please ask your question?
Yeah. Thanks, sir, like for giving us a wonderful like a seminar about our satellites. It's an eye opener for a lot of people. I have a few queries. Like I will combine it, but you can answer that one. Is there any centralized agency to monitor the satellites roaming around the Earth orbits? And the same thing, like okay, if China is doing some spying satellites over there, do we send any satellites to destroy or demolish that one? Or like, is there any agency to check what purpose you are sending the satellites or something? Can we use, like, for example, I develop a satellite. Only thing is the launching is the issue. Like now, but the Richard, the Branson has sent his own spacecraft. If we have the capability, not going with the ISRO or something, can I launch my own satellite and do my purpose, solve my requirements and other thing? So these are the queries. Like probably you can answer whatever you feel.
Yeah, actually, that's a good question. Actually, I answered it a while ago. The thing is, like, first of all, we have some centralized agency. We have UNOSA, it's a UN's, agency. I'm not sure how, like how effective, how effective UN is. It's the same as how effective in the space it is. The thing is, we cannot control all the countries. For example, UN is doing its absolute best. Still, it cannot control all the countries. Same goes for the space. UN is trying to do its best to control and use the space for good things. But the same happens. Some countries, for rebellious against it, they will go against it. But things are becoming better in space. Even scientists want to collaborate. For example, India is working together with China to send an experiment on the newly launched Chinese space station. So space basically promotes brotherhood, unity and everything. But still, there is an agency called NORAD, which basically monitors all the things. Like even if you're launching a small ball or some junk into space, they will monitor it. They have the capability. And now a lot of private agencies are also coming to spy, like what people are using, like why satellites are getting launched. The one the Branson has developed, which is a suborbital one. It will go to space and it will come back. It can't stay in space. But people like Elon Musk has developed their own rocket, which can eventually put you in orbit. But to launch a rocket, it's not easy unless you are in countries like China or Russia. There also without government support, you can't launch. So there are a lot of things. Space is hard. There are a lot of rules and regulations you need to develop. But still, even after that, you are like Iron Man who's developing the armor in a small cave. You have that kind of capability. You are building a rocket in a secret place and launching it. Even if you're launching a satellite and people like if the government, some governments are thinking you're doing something bad or against their core values, they can shoot down your satellite. Many developed countries, including India, are having anti-satellite missiles, which means they can destroy your satellite. Even though that is not a good practice, it will create a lot of junk in space, but you're doing something which is damaging their integrity. There are possibilities they can shoot down your satellite. And recently, there are a lot of other mechanisms coming. Instead of shooting, recently Airbus has developed a satellite, a robotic mission, which can go and capture your satellite. Basically, like, they will put a net kind of thing above your satellite. It is basically like, how thief is running, you'll go and put a bed sheet over him. It can take a net and cover your satellite like that. So it will deorient and, dismantle your satellite in space. So you can't do. So there are a lot of defense activities are also going like.
Oh, okay. Great to know.
Next question from Mr. Darshan. Does Nano Satellite survive in Van Allen belt?
Sorry, can you repeat?
Does Nano Satellites survive in Van Allen belt?
Depends upon the design you can do. But I told it already 2 satellites went to Mars, 2 CubeSats went to Mars, which means it can survive.
Thank you. And next from Mr. Sriram. How can nano satellites help in Indian archaeology?
Archaeology, I don't think it can help in like directly. Maybe it can help with capturing images of some place or something like this. So I'm not sure about it.
Thank you. And one more question from Mr. Revan. What is the most complicated thing in making satellite and launching satellite? Which is more complicated?
Everything is complicated regarding building the satellite, because even putting a screw is very complicated. You can't just take the screw and put it in the hole. You can type it. We have, like, you might have already, like, aware, like, in many fields.
You are saying.
Sorry.
Like example, you said for soldering 1,500 pages.
Yeah. Like, we have a special screwdrivers which can monitor how much torque you are putting. Okay. So you have to document. For example, at this place, at this hole, every hole has a name. So in the thing, at what time, you have put the screw and how much torque you have applied. You have to document all this. So everything is complicated.
It applies for this nano satellite as well?
Of course, nothing changes.
Because you said, so these kits will be made by the kids at home, right?
No, the thing, these are the suborbital fun sets I'm talking. These are the suborbital one. After students build and send to us, we will do a lot of corrections on them. But I'm talking about the professional ones, professional nano satellites.
Because we will not have that much perfection.
No. Yeah. But you don't need to worry about it. We'll take it.
There is another question from Mr. Nishant Subbu. Hubble Space Telescope has a lifespan of about more than 30 years and is still alive. But why does James Webb Telescope's lifespan said to be just 5 years?
It's basically one thing. Space agencies, they will put the life estimates as small as possible during the beginning. Okay. So even like the Curiosity rover, which had only estimated lifespan of 6 months, but it worked for 10 plus years. So the thing is, like, if you like straightforward answer I'm giving. So if you're having shorter estimate and it's working better, nobody will question. But if you're having a bigger estimate and it underperforms, they'll put a like investigation commission on you. Why it underperformed. So that's why most optimistic things they'll put. Like it is not like that. How much data they need to conduct a basic investigation and how much time it requires, they will calculate that. So that is the basic mission life. So after that, whatever the time it operates, it's additional data. So the James telescope is having 5 years of lifetime, but it can perform for like 20 years or more also. But we don't know how the fate goes. It can also underperform, like just 1 or 2 years also things may fail. For example, the Kepler telescope, which underperformed, and like it doesn't have the same lifespan of Hubble Space Telescope. So it is up to the engineering and the efforts. And recently there are a lot of things and comments going on in the space industry that the telescopes and satellites we manufactured in older times are more reliable than the one we are manufacturing recently. That's the thing going on, because at those times everything was manufactured by hand. We put humans on the moon where we didn't have AutoCAD or any sort of computer aided modeling. Everything was manufactured in drafted sheets and tables, but we put that. Now everything is automated, and generally people are telling the production quality in recent times are getting lower. But it's a general statement people are thinking, and people are doing more investigation into it. We need to see what is the truth. But the Curiosity rover, which was launched in 2012, is still performing today. Like it was around 2 to 3 years it had the lifespan, but even after 10 years it's working excellent.
Depends on the quality.
Yeah.
Next question from Mr. Shankar Narayanan. Can we get the nano satellites back to Earth after the study?
No.
Can we carry out biological studies using nano satellites?
Yeah, we can do. You can basically send like small microscopes or different kind of elements and sensors for that and get data from that. In fact, next year we are planning to do a biological mission on one of our satellites.
So all these nano satellites, what these kids are going to make, so they can come up with their own ideas, the parameters.
No, that is going to be the next level. See, this is the first step. This is the first step where they will learn the basics, in a structured way. And then we are already having another program running called Space Taxi, but it is as of now only open for institutions. You may be asking, what is Space Taxi? For example, the concept is you may be knowing Uber Pool, right? Where in a Uber taxi, multiple people can share the taxi and they can get dropped off on the way, which will make the entire ride more economical. So instead of just putting one sensor in one satellite and making it dedicated for that purpose, what we are doing is we are making our satellite like a taxi, and multiple students can send their experiment on board. Which will, for example, if a satellite can carry 10 sensors from 10 different institutions, the cost will get reduced 1 by 10. So that's why we named this program as Space Taxi, which is, of course, Space Taxi. So once you learn all these basics, then you can come up with your advanced experiments, customized experiments, and we will be very happy to launch it in our Space Taxi.
Thank you. And how far can a nano satellite travel maximum?
It's not like how far. I told, right, as of now, the greatest distance nano satellite has traveled is beyond Mars. So in the upcoming days, we will see like how this limit is going to get stretched. Definitely, it will get stretched.
Thank you. And next question from Mr. Segu Yusuf. How do space industries maneuvering space debris cleaning?
There are a lot of new startups and companies coming. I told, right, like you can put a bed sheet like a small net and you can capture the satellite. Like that, there are things where you can put the thing and you can pull it towards the Earth and you can make it deorbit. A lot of new concepts are coming. Even ESA, European Space Agency, and also NASA, they are funding a lot of such programs as well. So, but one thing is we cannot clear all the space debris we have put so far. Like so much we have put. But one thing is now acting responsibly and try to not put any debris anymore. So that's why now the regulations are very strict that, I told that within 20 years, you have to deorbit your satellite and burn it in that atmosphere. So such kind of things are coming.
Next question from Mr. Shankar Narayanan. Will you be letting students to launch satellites with camera module at a $350 price?
No, the camera module will be very expensive. So at $350, we are only allowing the sensor. But if they want to launch something like camera or something, the cost to orbit, it is suborbital module. But in orbit, if they want to launch something like camera, it will cost them somewhere like around like $7,000 to $10,000, something like that. But soon, by next year, we are also allowing that in suborbital as well, and costing will be somewhere around like $2,000 or something like that. Where these things cannot be done by a single person. Space can never achieve by a single person. So students can form as a team. Like institutions can form a team. They can collaborate and do such programs. And already you don't believe, already couple of schools like high schools from Tamil Nadu are doing that. We are going to launch their small payload like camera in coming August. So that is definitely possible.
Sure, you will see more from TEF as well now. And next question from Ms. Uditra Sivakumar. What will happen when satellite crash with another satellite? Everybody is curious about the crash.
Yeah.
One more question followed by the same. What all problems are caused by this space debris?
So when two objects collide, what happens? It will just burst into a lot of, but the problem is it has also a lot of fuel inside. Many satellites, they have fuel. So it will also create fire because they also have oxidizer in it. In space, fire won't happen, but they also have oxygen inside. They are hyperbolic fuels. Basically, you don't even ignition. The moment they come in contact, they will burst. But the thing is, it is the aftermath. Thousands of small pieces will get released, which you can't track. For tracking from ground using ground-based radar, the object needs to be at least 5 centimeters. There can be a lot of small things which can ultimately become dangerous to other satellites and ultimately dangerous to the human life on Earth. For example, right now there are around 10 people in space. From Chinese space station, 3 people, and in International Space Station, 7 people. The space debris is becoming a great concern for the astronauts in ISS. So this is really becoming a huge problem, and scientists around the world are trying to solve it.
Thank you. One question from Ms. Anisa. How do you foresee the future of nano satellites and their contributions to the humankind?
It's going to be great. I told right from just being a scientific and educational mission, it has grown to a multi-billion-dollar industry, and it's going to grow from now. And satellites are even getting smaller. I think bigger satellites are going to like fade away. Even ISRO and other like other agencies are considering about launching nano satellites for communication because they are more effective and you can quickly replace it. The like you can update it. For example, one geostationary satellite will be in space for around 10 to 15 years. At that amount of time, lot of new technologies get evolved on ground, and your satellite is getting outdated, right? So if you're having nano satellite and they're very like economical, you can replace it every 2 years or like 3 years, which means you can continuously provide more efficient and more advanced services to your customers. So nano satellites are going to be the future.
Can this help in medical field as well?
Yeah, there are a lot of, you can discover a lot of new tissues, like new medical compounds and everything, and that is why we have like a lot of laboratories like International Space Station. Private space stations are going to come in the upcoming days. So like doctors, uh, half of the people like many astronauts are actually biologists rather than aerospace engineers. So
Actually,
you can see.
it's the same. Like everyone is looking forward. Will there be an Indian space station in future?
Definitely, I hope. I'm also looking forward to that. But the thing is, India has different views for the space. Dr. Vikram Sarabhai's vision is more about making life on Earth better rather than focusing on too much of research on other planets or something. That's what happened even when ISRO started to launch interplanetary mission. Many people were questioning that the founding father of ISRO, Dr. Vikram Sarabhai's focus itself, the vision itself is making life on Earth better. But why you are shifting to other planets and everything? But when we want to keep ourselves updated and be in the international stage and contribute to the research, we have to do certain things. But I don't think, like, depending upon the India's economics, the budget we are having, the population we are having, it is not just the space industry or technology, the socio-economic factor. It will be very hard for us to, like, technologically compete with NASA or ESA in recent years. But who knows? In the future, a lot of things can change. But one thing we ISRO and Indian space companies are good at is doing things which actually we need and which actually makes impact on common man's life, and that is what we are good at. We spend every month, every rupee carefully, and we make sure things are becoming useful. We don't need to like do things which are very expensive or something. So I'm very proud of Indian space program because we do what really which is needed.
Thank you. And Mr. Abhinav was raising hand for a long time. Mr. Abhinav, can you please unmute your ask your question?
Hello. My
Hi.
question is, how can a shoebox size satellite have all the features as a normal satellite?
Yeah, I think I answered this question in the earlier part of the webinar itself. The basic answer is the computers used to be as big as a room or a house, and due to the latest advancement in technology, nanotechnology, and a semiconductor industry, the size of each component has reduced. So we can have a very capable computer in my mobile itself. My iPad is more powerful than most of the computers out there. So that is how, satellites are also basically computers, flying computers. So you're using the same technology in satellites also. So things can become smaller.
Because it's still unbelievable when you are showing that small board. It is still unbelievable.
See, I'm not claiming, this satellite will be doing the same as a, 700 crore geostationary satellite which is in space. But the thing is, to go to space, you don't need to be always like that. This thing also can do space. It is, for example, if we consider the history, if you look at the history, it is not just few people can do certain things. Even other people also can do the same thing, but differently. Okay, that's what we are making the space a platform where different kind of people can use it for different applications. It is not just only the like people at that level. Same thing happened with automotive industry in India. It only used to be like very expensive cars, and only the millionaires can afford the cars. And Tata Nano got released, and Tata Motors and other people made car affordable. It doesn't mean that like Renault Kwid and a Tata Nano is equivalent to an Audi AA, but both have its own application, and both needs to be in the market to serve different kinds of people. And same applies for the space industry as well.
Thank you. Next question from Mr. Puhan. Which is more important for making a satellite, physics or material science?
Everything, I would say, not just the physics or material science. Programming, you need a good programmer is very important. It is like the satellite is the body, and program is the one which gives it the life. So that is important. Physics, material science, chemistry. If you're having engines, and material science is also part of physics and part of chemistry. And you need electronics for launching it. You need facilities on the ground. Even civil engineers will need, and budgeting and making it. For what will happen if you're launching a lot of satellites and not running the business properly? You will end up in bankruptcy. So you need business people to run the company. So they are also important. So it is complex teamwork.
Yes. And there is a question from Mr. Mariappan. I think this is everybody is looking for. Is there any training program for kids, which you already said, students from Space Kids? How kids can approach Space Kids, and what is the minimum age qualification you expect to train students?
As of right, it's 8 years old. From 8 years old, we are starting. And you can go to our website, and we have given a lot of information there. And from there, you can check.
Sure. And the last question, that is from TEF, Mr. Segu Yusuf. We would like to collaborate with you for our DOT, that is Development of Tamil Nadu Mission. What is the roadmap should we follow?
That's a very good question, and it really needs a separate discussion of its own. Yeah. We are really looking forward to work with TEF and DOT program, and it's really required. So what I would say is we can start up with something which is immediate instead of I always like quick actions, like getting started with something immediately. So we will have a meeting, like a separate meeting. We will come up with a roadmap, and we will come up with a plan, and we'll see what can be done. But we'll be very happy to work with TEF.
Me too. Thank you so much, Mr. Rifat, for your.
And I personally want to answer one question, which is asked by Ms. Rehana, and she was asking, all the technology will be, when initially we started, it will be used for a good thing, and then end up in other thing. And she's also asking, humans who are existing on the earth, who are not able to, to basic needs. Or why we need such huge investments in other industry. It's really sad. Even sometimes I think about it. Why we do. It's common to have thoughts like that. But if you just think like that and do not invest in the future, you cannot be part of the future. It is not just thinking about, oh, I'm very poor, I can't do this, I can't do that, I need to do that. Everybody in this world has their own role. And there are people working to the betterment of the society, and there are people who are working on the betterment of the future. So everybody will take care of those sectors. And ultimately, we need to be prepared for the future, and that's what we are doing. And it's common, like whatever you are doing, it's nature of human, it's nature, it's a philosophy of nature. So we can just try our hard to see how best we can use it for the good causes. And in recent technologies, we are coming up with a lot of algorithms on automated things. Even the Facebook, the Twitter, everything, it's becoming better. And there are a lot of technologies are being used for better things. So we have to see things from our eyes. If we are looking at with the negative eye, we will see the negative aspects of it. If we look at this from the positive eye, we will see the positive aspects. For example, there are nano satellites which help, like, predicted, hurricanes. like previously, which helped the people, like tens of thousands of people, to evacuate at the right time. So those kind of lives are saved. So what would you answer? So if we don't invest in such technologies, those lives cannot be saved. And there was one incident. I've just we will close with that incident. There is a technology which is being developed, okay, which is right now in International Space Station. It is basically beacons. This beacon can be, stored in vessels, like fisherman problems and all we are seeing, right? So you can have it in both. If some kind of problem is happening or some storm is hitting and ship is sinking, you can activate that, and satellites can exactly pinpoint where you are and they can deploy rescue forces. Such thing happened in European, in a European country. I forgot the country. The ship, got hit by the storm. It completely sank. All the crewmate died. Only one person survived. He was, sitting on top of like floating like in Titan. He took that satellite transmitter and he activated that satellite transmitter. Immediately, the space station, which is having the sensor, detected his location and it was informed to the local authorities. And within few hours, he was rescued. Just imagine this kind of impact we can create. And if like hundreds of such nano satellites can be created and put in the orbit, the entire sea travel can become safer. The Tamil fishermen who are dying in the border and other problem, if they can have such kind of solution, just imagine what better things we can do.
Yes, sure. And what is the difference between GPS and this nano satellite? What you're talking about, it is similar to...
Yeah, GPS, for example, GPS will give you the location. For example, if you are on the ground and you don't know your location, the satellite will tell you are here. But now you know you are here. But the local authorities needs to know that you are here. Now, what the satellite will do is, GPS will basically tell you that you are here. This satellite will tell you that person is stranded here and he is in emergency. You need to go and save.
Okay.
Yeah, there is a difference.
And just one more question from my side.
Mm-hmm.
Like, what will be the difference between, as you know, like you said, it can measure temperature, it can measure, it can predict hurricane, everything. It is all already there with the big satellites, what is in the space already. So what will be the difference in these nano satellites and that big satellites? What will be the difference?
Beautiful question. This is a beautiful question, but I answered in the webinar, but I just covered it simply because of the time being. So the thing, orbital mechanics, which plays a huge role. When you are putting a satellite in orbit, for example, the satellite is coming over T Nugget Chennai on like what is today, Friday. Okay, for the satellite to come exactly on Chennai at the exact point, it will take another 14 to 16 days, depending upon the orbit. So you cannot track it 24x7. Okay, when you are having nano satellite and you are deploying, instead of one big satellite, you are deploying 50 bigger satellites. Smaller satellites. So one satellite will come here and it will cross, but another satellite will be ready to cover them. And once that cross, another satellite will be ready. Like 24x7. Yes, 24x7 you can cover. So in cases like hurricanes and everything, having like 24x7 monitoring is very important. You just go to Planet Labs. There is a company called Planet. You go to their YouTube. They are predicting when India did surgical strike. Their satellites were able to detect how many buildings got destroyed. Which is ultimately cannot be done using a bigger satellite if it is not over that particular position. But with their nano satellites, at any given time, one satellite will be above you. So you can do it. And you can do better service. I told, right, you can update it. It is more economical, which means you can give constant updates. Instead of serving you...
More accurate also, you mean, than the bigger satellites? It will be more accurate.
I'm not telling to, we cannot say it is more accurate, because bigger the sensor, more accurate it is. But sometimes the frequency is more important than the accuracy and resolution. So that's why, for example, the company called Black Sky and Planet Lab is also having such system. They have bigger satellite and smaller satellite. What they are doing is, first they will scan with smaller satellites. And once they find something suspicious, like they want to take bigger, like better detail about it, they will send a bigger satellite, focus on that location, and they will collect more info. So this is a beautiful, like it is a beautiful orchestra. It is like a ballet dance of complex systems working together to make life on Earth better, and that's what we are trying to do.
Very, very good. Very good. Thank you. Actually, there is a lot of wishes flowing for you in the chat box because everybody
Thank you so much.
positive answers. Everybody is giving you good wishes. And I would like to invite Mr. Sri Ganesh to give you a vote of thanks to end this session.
Thank you.
Just stay tuned for a couple of minutes.
Yeah, I'll see you.
Thank you, Mr. Rifat. That was a very informative and very interesting speech there. We learned a lot from your speech today. I'm sure it will be inspiring for a lot of students, budding astrophysicists and budding engineers. This would be a very informative and very motivating speech. So I once again thank all the organizing committee members of TEF and all the guests present here today on this August gathering, and thanks again.
Thank you. Thank you, Mr. Rifat.
Thank you, guys, and thanks to them. And see you soon.
See you soon.